Alrighty, I'm gonna take the pulley off this generator here. And that nut has been on there a very, very long time, so I'm gonna heat it up. Yeah. When I heat stuff up like this, I'll take and heat it around. But ultimately, I'm going to concentrate on one spot. And it'll be on a flat where it's the thinnest. Yeah. Now this shaft here, I don't know if you can see, it's old and it's hollow. So you really want to be careful with old things like this and try your best not to damage them. Now a lot of people will do this cold and use stuff like coil and what else is a WD-40. But I use the ultimate. Okay, I'm concentrating that right on there. Right on that flap. And in the vicinity. I think you can see all that. This is a special edition of a crack pipe lighter. It's called the Hunter. And you can also fire up some Parmesan cheese with this one. It's getting pretty hot there. I'll keep it right on there right now for that. So, if you've watched me for any length of time, you probably know what I'm going to do next. I just want to make sure that's, good and hot. This is kind of a small torch and it's not going to overheat anything. But yet it is quite hot. No, heat it right. Maybe that top half. So, but I'm going to concentrate it right there for a little bit. Okay. The next step is dirty piece of beeswax, but it's pure beeswax. Okay. So that beeswax really penetrates. If it's hot enough to melt it, it'll get into it. And if it does not come loose, the thing you really need to do, and we might because I refuse to damage this, is let it cool down, heat it up again, and we'll try again. Okay, let's try to get that off. And I will put on a glove. Left-hand glove. Grab it like so, and in this hand I have an impact wrench, and I got to crank down about half, 45 pounds of pressure. Okay? And it's right on there. How about that? Okay. Let's see if that just comes off. Gonna need two gloves now. I hope you can still see where we're at. I hope you're all doing good this evening. I needed a little diversion from everything else, so I decided to do this. This is a generator for that old 49 Chevy out there. But it's not 49. It's later. Okay. So that came off nicely too, and I can see the beeswax got in there. Oh, that looks really good. Yeah, see that shaft's in good shape. Let's see if we can get that key out of there. Yeah. Oh, if I can get a hold of it, it's still pretty hot. That's pretty shallow. I don't know if I can grab it like that. Almost. Yeah, I got it. Here, let's do it so you can see. I just grab it with these wire cutters here and use it. Oh, kind of use it as a pry. Get it up and out. Okay. Okay, I'm going to do something and grab a couple other tools. Have a nice drink of tea here. Okay, I will be back in a minute. Okay, back here with the 3/8 air wrench. I'll start knocking this thing apart. Pretty simple. That's it. And an extremely poisonous lead hammer. Let's see if there's anything else holding. No, I don't think there is. Here it comes. Got a little locating pin right there. Plain bearing. Isn't that cool? That is just cool. Okay. Got a plain bearing. 12-volt generator. Dirty. Looks like there's plenty of meat on the commutator. Let's pull it, see if we can't get it out this way. Okay, those brushes and stuff really need to be cleaned up. And what are we looking on this end? I'm not sure if I have to knock this seal loose. Let me see. If it'll come on out, it looks like it might. Got a spacer. Let's see where we're at here. See if you can see what I'm doing. I'm just going to try to tap it out with this lead hammer in my hand. There we go. Spiders and everything. Look at that. Look at that plain bearing in there. I'll take all that apart there. It's probably got some packing, got a sleeve, and a split spacer. And the woodruff key. Okay, I don't see any real damage to this. I'll tell you what, I really believe that to be the original armature for this. The spider eggs of it. Okay, got a spacer at that end. I checked the in play, and there was just hardly any in play on this. It's really a pretty tight unit. But, you know, this stuff's caked on here, and I saw a brush holder was loose. Hoping the fields are good. I'm sure they are. I'm sure everything's good. I have a armature growler buried somewhere, but I don't think I need it. But what I wanted to show you is conditioning the commutator. I've done that on the Monarch 10EE generator a little bit, and I'm just going to do it again here, and we'll be back with that. I'm going to mount this in the lathe. Upon further examination, that is a ball bearing in there, and I should have known that. And it's good. It's got grease on it. It's good. We'll clean that up. Yeah. Yeah, this is nice to find this in good condition like this. Look, I want to drop that on the floor before I get it in the lathe. So, okay, I'm going to set up the lathe for this real quick. At this point, I'll do a little bit of a rewind into past videos I have done. Now, what I just done is that 4-jaw chuck with that piece of steel trued in it was in the lathe, and I decided to work on something else, and it could be an emergency drill. So that's the reason I fit these chucks very, very carefully. The back plate to the spindle nose. Now, I was kind of shocked. I knew the specifications for the tool room lathe, the Monarch 10EE, they printed. But national, whatever, specifications, international, whatever, for engine lathe, it's a little bit hard to find. And I happened to find it in a later Dean Smith and Grace lathe manual. And the maximum run out they were talking about on a D16 spindle nose is 1/2 thousandths for face run out, taper, or maximum is 1/2 thousandths even for the internal taper. And kind of the reason for that, lathes improved, and I've talked about this before, and then they go, hey, it would be better if we ground the spindles in place. So this 1941 lathe does not have the spindle grounded in place, and it has an error of about 3.5 tenths. Under, well under that 1/2 thousandths. So because of that, I've had to put these back plates on and mark them. This one is already marked and it wants to be where it was. And you have to put them on exactly the same. And then you have to get them so the taper fits this taper with no shake. This is the locating taper. Now I thought I'd just stop and point out that I'm able to do this, and I'll be able to put that chuck right back in here. It'll run within 100 millionths true. Okay, so I'm going to stick this chuck on there. This is a Buck 6-jaw. A just true. And it's only held on with 3 out of the 6 pins, which is common for the lighter weight attachments. Okay, I gotta find my other wrench here. Here it is. There we go. 2, 4, 6 it will be. Come on. And I kind of creep on it a little bit, you know. Creep up on it. Don't get them all that tight at once. You skip 3, go to 2, skip 1, go to 6. Just a tiny bit of gain on there, reasonable pressure, go to 4. It's on there. Okay, I'll reset up and I'll get what's needed into the tailstock end. Back in a second. Okay, now this may be an automotive armature, but it could be anything. And I'm doing exactly the same with this that I would do with anything like this that was had some length to it and needed to be chucked up. Okay, so if you've seen my past videos, you know that I grind the chuck jaws in place. Okay, all of this stuff's fit. It'll go back on exactly the same if I take this off. I chuck this up and I expect it to run pretty true at the other end. And it does, and I'm going to show you that I'm not cheating here. Let's put it right on 0. Okay, I'm going to start rotating it. It slipped back one, but I would say I'm trying to really determine. I could put a 1/10 indicator on it. It's better than a 1/2 thousandths. Oh, yeah. I'm going to call it a 1/2 thousandths run out. Isn't that interesting? So that's very good. And I noticed another problem I want to take care of real quick. This rear bushing was starved a little bit of oil, I can see, and slightly scored. So I'm going to do a real quick, just an easy lap job on it. Instead of taking emery cloth or sandpaper, okay, we're going to turn back the clock decades, and I'm going to show you how to do a quick job. Okay, we'll be back. I hope you understand where I'm getting at here. All of this is running true within a 1/2 thousandths, plenty good. So I'm going to go ahead and we're going to lap that and then proceed. Okay, this is a plumber's sled here. It's like a ribbon, and I cut a piece off here. So I'll set that aside over there, and I'm going to make a quick lap for this thing, and it should not be over half the length of this, the little lap I'm going to make, okay? So I'm going to kind of give it a little bit of a guess here. A 1/3 to a 1/2 covering. Go and drop it open, find it, I see it. Way down there. Down there's Buzz. Okay, there it is. Oh, I'd like it a little bit longer, but you know something, that'll be fine. That will be okay. Okay, so that'll fit good enough. And what I'm going to do next, let's see if I can find, here's one. I'm going to take this little pocket knife and I'm going to scratch some grooves into this thing in a crosshatch. So I'm going to go this way, hopefully not slice my finger. mostly across this thing. Okay. So then you turn it like this, and you go again. It doesn't have to be perfect. Good thing, huh? Okay. Okay, you remember the grooves in the flat lap. That's just kind of what this is all about. Okay. That looks really good. Where is that? Hope it didn't go too far. Let me see if I can see it. Okay, I gotta chase down the lapping compound. I'll be right back. Okay, right back here doing the same old thing, but a little bit different. I got the grade C clover compound in a green can, like a green wheel, silicon carbide mixed with oil. It comes with oil in it that's very much like sun and honing oil, and I just add honing oil as I need. So what am I doing? I'm going to charge the lap. So I got the compound on there. Now let's get that can out of the way. I'll knock it over. And I'm going to take this roller and I'm going to roll that compound, push it into that lead. Again, that's charging the lap. And this is really better than using emery cloth. I hardly use emery cloth at all because I know how to do these things. Oh, that looks so good like that. Okay. So now I'm not gonna wrap it around just yet. I got one thing I gotta do here. And let's see if I get things fired up. Switch is on. American rotary going. Okay, it's gonna get loud. Whoa! I don't know why it didn't start. Try it again. There we go. I'm going to start it up and run it out. I think, oh gosh, we'll start it at 264 RPM here. Okay, first thing I'm going to do is take the high points off with a file. even feel across it. You can see the scoring, but it's not really that severe. You know, when you're looking at a bearing like this, you want to think of percentage of contact. And I think the percentage of contact will be plenty good enough. Okay, I'm going to stop the machine. And I want to go up to the next speed, 351. Okay, I'm going to start applying this and wrap it around. Now I'm going to go in a honing type motion. I think I'll stop it. Come on. Now really get that formed on there good. Okay. Now I'm feeling that. And I'm feeling the roughness come out. Now generally, if you're using emery cloth, you'd really want to speed the machine up. This is only running 350. Okay, I like to reverse. And it's so easily done on an Axelson. Okay, I'm going to put a crosshatch on it for oil retention. Okay, grab a piece of paper towel. You don't want to use your shop rags. All right. Okay, let's look at that. Now you can make it shinier with emery cloth. But that's a better oil retaining surface and it's straighter. It is. Okay, so now we're going to work this commutator and we need to support this end. But we're not using a tail center. Even though this has a center hole, you're not supposed to use that. So I will set up with a tool that you can use and talk alternatives at the same time. Okay. And the bird is the word. Okay, what we have here is a genuine Jacobs. I guess I'd call it a generator chuck here. And you loosen this collar right here. And then this rear sleeve retracts those brass jaws. So you want to be sure and put a good bearing surface, into those brass jaws so you don't damage them, right? So that's why I cleaned that up and lapped it before this point. Now, both the Atlas and the South Bend 9-inch came with accessories with this chuck, this one, and then it had kind of a similar looking one, but it had steel jaws that would drive this in. But I've got this 6-jaw chuck in there, which is a nicer situation. But you can see that it's holding the entire armature true by the bearing surface. And that's why they do this instead of holding the rear of the armature with the tail center. There is a tail center in there, but you're not supposed to use that. You're supposed to use the bearing surface, and that's for good reason. And the reason is that these armatures, they spin up a few thousand RPM. And let's see, get that on there good. Don't want it too tight. Yeah, they spin up fast, and there we go. You don't want them galling. And what happens on the bearing surface, and what happens at higher speeds, if the commutator is not true with that bearing surface, and you true it with the tail center, and it could cause this to be out of round, and that causes the brushes to dance. So if this is out of round, you got the brushes, like motors have. A generator is just like a motor. You can put electricity to it and make it spin, just like a motor. So you can actually test them that way too. So what I've got is the proper deal to hold it. Now, if you do not have that, then you can use your steady rest. This is just a more convenient thing than using your steady rest. Use your steady rest for armatures that are too big for the capacity of this chuck. And I had to do that with the 10EE armature I was demonstrating a while back. That armature is still sitting out there. I don't know. I have to send it to Pakistan to get rebuilt, probably. Under $1,200, I don't know. I don't know what it costs to, to do that kind of thing anymore. Okay, so I'm going to be back, and then we're going to do the. Oh, I got one more thing we should check out real quick while I'm thinking about it. And I want to see what the run out is. I got this thing supported pretty good. Now let's get an indicator in there. Have a look at it. Come on, get in there, indicator. This is a Noga holder that I bought decades ago, and it's just really nice. Let's have a look here. I'm seeing a little bit around, I'm seeing a couple thousandths, I think, and maybe a high bar or so. Okay, that happens. So these things, you know, they run, and a bar will raise up and cause the brushes to dance. And you might not notice that happening, but it lowers the amperage and the voltage coming out of these things, and then you're going to have problems with the other parts of the system, like the regulators and stuff. But that's not our concern here. We're doing the metal work, metal removal. We're not putting any on, that's for sure. Okay, I will be back with the next exciting step. One more look at that. It's a couple thousandths. You see that when you, I did a video and I talked about the 2,000th limit, and we're there on there, so we've got to correct that. Okay.